In today's video, we're going to be looking at a few examples from lesson 23-3 in your springboard. And this lesson starts on page 314 in your springboard. We're going to be using our new trigonometric identities to verify other identities and also using those identities to solve equations. Here in example A, we're asked to verify the identity that sine theta plus 180 is equal to negative sine theta. Now this is an identity that we've seen in a previous lesson, and in that lesson we kind of just used the quadrants and the unit circle to figure out this relationship, but now we're going to use our identities to actually verify that this is true. So I'm just going to rewrite the identity here. Now remember, when we're verifying identities, we are trying to show that these two things are equal to each other. We don't yet know that they are equal, and so we can't be adding things to both sides or moving things from one side of the equal sign to the other. When we're verifying identities, remember, I want you to put up a wall underneath that equal sign and only work on one side or the other until both sides match. I'm going to start over here on the left side, and I see that we have sine of theta plus 180. So I've got two angles there that are being added together. So I'm going to use the sum identity for sine. It's on your sum and difference identities page in your foldable. And that identity says that sine of a plus b, so this theta is going to be our a and the 180 is going to be our b. So sine of a plus b is equal to sine of a, which would be sine of theta, times cosine b, or cosine 180 degrees, plus sine of b, so sine of 180 degrees, times cosine of a, cosine of theta. Now I notice here that I've got a couple values that we know from our unit circle, cosine 180 and sine 180. So let's substitute those values in. I have sine theta times the cosine of 180 degrees, and that's going to be -1, plus the sine of 180 degrees, which is 0, times cosine theta. So sine times -1, I can just rewrite that as negative sine theta, plus, and 0 times cosine theta, of course, is 0, and negative sine theta plus 0 is negative sine theta. And so both sides match, and we have verified that the identity is true. Let's move on to example B. In this example, we're given an equation to solve. So we're going to use our new identities to actually solve an equation. And here I see we have solve sine of 2 theta minus sine theta equals 0. Now previously, when we were working on equations, it was important that we try to get the equation where it had all of the same trig function. And in this case, we have that. Both of our terms here have sine. Unfortunately, they don't both have the same angle. I have sine theta and sine 2 theta. And if I'm going to be able to solve this, I need all my trig functions to have the same angle. To be just theta would be the most convenient. And so that's what we're going to do. We've got sine 2 theta here. We have a identity for that. It's a double angle identity because 2 theta, that means we're doubling the angle. So we're going to use that double angle identity for sine. Sine of 2 theta is actually equal to 2 sine theta times cosine theta. So I've just replaced sine 2 theta with that identity. I still have minus sine theta equals 0. So now looking at this, you might be thinking, okay, well great, now we have two different trig functions in here. What do we do about that? Well, remember, one of our strategies for that scenario is if we have a trig function that is in every term, we could factor it out. So notice here, both of our terms have sine theta in them, so I'm going to factor that out. Sine theta. And when I factor that out, I'm left with 2 cosine theta minus, and when I factor sine theta out from sine theta, I'm just left with 1. equals 0. Now that we factored, we need to set each of the factors equal to 0. So sine theta equals 0, or 2 cosine theta minus 1 equals 0. And now we're ready to solve. Now before we solve, let's remind ourselves the interval on which we want our answers is 0 degrees to 360 degrees. So I need degree answers, and I need all the degree answers that would be on the unit circle between 0 and 360. So sine theta equals 0. Remember, sine is the y-coordinate, so it's going to be equal to 0 on the x-axis. And that means that sine theta equals 0 whenever theta is 0 degrees, or also when theta is 180 degrees. Now our other equation, we need to solve for cosine theta. So I'm going to add 1 to both sides. 2 cosine theta is equal to 1. And then divide by 2. And we get cosine theta equals 1/2. So now we're ready to solve for theta. Cosine theta is equal to 1/2 at the 60-degree angle. And cosine is a positive. 1/2 is a positive value. So we want to think, where else is cosine positive? And that would be in quadrant 4. So I want the 60-degree angle that's in quadrant 4, which would be 360 minus 60, or 300 degrees. And so there's our 4 answers to that equation. I've got one extra example here for you. This is not really in the Springboard lesson. It's one of the practice problems. But I wanted to show you an example like this. So just find some room there in your Springboard or write this on a piece of paper. We're going to work a different example. 2 sine squared theta is equal to cosine 2 theta. So again here, notice I've got this double angle here, and on the other side we just have theta. So we need to use one of our double angle identities to replace cosine of 2 theta. Now if you look at those identities, cosine 2 theta actually has 3 different versions, 3 different ways that we can represent that identity. And so we need to make a choice here. We're going to choose the one that has sine squared in it, because notice in my equation, the other term in the equation is sine. It's also sine squared, but it is a sine function, and so if I can change the other side to have only a sine function in it, then we would have an equation that we could solve, an equation that was all in terms of one trig function. So the left side here, we're going to keep it as 2 sine squared theta. This is going to be equal to, instead of cosine 2 theta, we're going to replace that with 1 minus 2 sine squared theta. That's one of the double angle identities for cosine. So now we need to solve this equation. I'm going to add this 2 sine squared theta over to the other side. And I get 4 sine squared theta is equal to 1. And then at this point you have 2 options for solving. You can divide by 4 and then square root both sides. If you choose that option, you have to remember to do plus or minus. We continue to forget to do that, and so I'm going to go ahead and work this by factoring. And of course, if we're going to factor, I need everything on one side and the other side equal to 0. So I'm going to subtract 1. And I get 4 sine squared theta minus 1 equals 0. So now I see I have 2 terms and they're being subtracted. And I notice that both of those terms are perfect squares, because sine squared is obviously squared and 4 is a square number. And then 1 is also a square number. So I can factor this like a difference of squares. So the square root of 4 sine squared would be 2 sine theta times 2 sine theta, because the 2 times 2 would give me 4. Sine theta times sine theta would give me sine squared theta. And then, of course, the square root of 1 is 1, so 1 times 1. And then I need a plus and a minus. And this is equal to 0. So now we need to set each of the factors equal to 0. 2 sine theta plus 1 equals 0. 2 sine theta minus 1 equals 0. And I'm going to subtract 1. And I'm also going to run out of space here. Divide by 2. And so I'm going to go up here to the top. So my final, I'm going to have sine theta is equal to negative 1/2. I'm going to go ahead and solve this other equation first before I solve for theta. I'm going to add 1 to both sides. 2 sine theta equals 1. And then finally divide by 2. And we get that sine theta is equal to positive 1/2. So I'm going to have, let's say on this one, I forgot to give us an interval. Our interval here, let's say 0 to 2 pi is our interval. So we want all the radian answers that are on the unit circle. Well, let's start with the positive one. Sine is equal to 1/2. Sine of theta is 1/2 at the pi over 6 angle. And since I have the positive 1/2 and the negative 1/2, that just means that my solutions are going to include all the pi over 6 angles from each quadrant, because sine is either positive or negative in every quadrant, so we're just going to include all 4 of those angles. So my second quadrant angle would be 5 pi over 6, where sine theta is also positive 1/2. And then we move on to quadrants 3 and 4, where sine theta is negative 1/2. That happens at 7 pi over 6 and at 11 pi over 6. And so that's the final example for this video. On the next slide, this is our assignment that we will be working on in class tomorrow.